ITD 130 Mod 2. We're going to look at how to get data, how to extract data from tables. So we're going to do a PowerPoint first. So let me share my desktop with you. And let's look at this. All right, so in Mod 1, we learned how to do some very interesting things. We learned how to create a database. We learned how to create a table, alter the table, insert data into the table, those kinds of things. Now, as a beginning database person, those aren't the things you typically do. Typically, the database administrator, the DBA, okay, will be the one that creates the structure. There's a whole philosophy of how to normalize databases and create the right tables, that kind of thing. Your application programming interface will typically be doing the insertion. By that I mean, like when you go to Amazon and you buy a book, okay, there's a Java program running on the backside, and that Java program is the one that inserts you into the customer table, deletes or updates the inventory, okay, to take one out of inventory, inserts into the sales table, those kinds of things, and they're done through the application interface. And we talk about those as you take your programming languages. The thing that's real critical here is to be able to extract data. And so most of ITD 130 is to look at how to extract data, how to get information back out of tables that already exist. Not changing the data that's there, but just retrieving data in a certain form that we want. In Mod 2, we're going to talk about a pretty straightforward concept, which is how to get it from a single table. That's why it's a one-week module, is because we need a lot more time when we start extracting from 2, 3, 4, 5 tables at once. Now, as you go through and do this, I'll do some examples for you. And what you want to make certain that you do is that you have the databases, the ERD, that entity relational diagram, that diagram I had for you, and the table column names and the sample data in the table printed out, probably. That's what I do, and it sits in front of me. As you're learning to do this, you're going to want to go, and I'll show you how to do that, and say, gee, I should probably get 5 rows if I do this correctly, and then check to see that you do when you run your SQL statement. In reality, you can't do that, okay? There's terabytes worth of data, and a SQL statement might return 500,000 rows or something of the sort. You're not going to go through and check 500,000 rows, but as you get better at doing this, you get more confident that your SQL statements are correct. There are ways to say, let's return the first 100 rows, okay, so that we can at least see some sample data to make certain that we're at least getting back what we think we should. But with the ITD 130, we're talking about, 4 tables, 10 pieces of data in each table, something of that sort, a very simple data structure for our tables. But everything we're doing here is valid, whether there is, a kilobyte's worth of data or a terabyte's worth of data, and so it's good things to be learning. How to extract data from a single table. All right. It is one of the most powerful features that we have, the idea to do a select, okay, to select and return data as we go. I just want to mute my other computer. There you go. So we need to look at this select statement. Very, very powerful when you do that. In its very simplest form, it is select whatever columns you want from whatever. We should be back. I'm running 2 computers because for some reason we're getting this thing to cut out, and I'm not sure why, and I want to make sure we get this recording done. Okay, so if we have an employee, the columns are the attributes, like the first name, last name, city, state, zip, and the rows are the individual employees that we have as we go through. All right, so let's go and look at the next one. All right, let me make certain we got it there. Okay, I think we're rolling again. I don't know. So select asterisk and location. Asterisk means all of the rows. So we can use asterisk kind of like a wildcard to select all of them. That would give you the exact same result as select the loc ID, street, city, state from location, if those were the fields that you have. A lot of these examples are coming from that films database that we have. And so notice the title at the top of these is the actual name of the column when the table was created originally. You can use that asterisk in place of the column names. It returns all of the columns. You can use the word distinct. Distinct only returns unique entities. So if you say select distinct city from member details, we will see one row for each city. We'll just see a list of all the cities that happen to be represented by our members of our film club. You can do it for more than one column. So if you say select distinct city, we get all the unique cities. If you say select distinct city, zip, you're going to get one row for each entry for a unique zip code city combination as you go through. Aliases. Aliases have nothing to do with changing the actual table. It just changes that title that comes above the column. You may want to change that. So the actual column name in the database is last name, and if you say select last name from pets, it would show that column title as last name. If you say select last name as owner, then the table has the column name last name, but the printout actually lists owner above that column, just kind of for printout's sakes. Select from, the only two phrases in our select statement that are required. Very commonly we use a where to filter your results. We saw that in the previous chapter, okay, and we're going to continue it here. Where sets up one or more conditions that must be satisfied by the record before it forms part of the result set. And so you can filter out your results. So if you say select F name, L name for member details where city equals big city, you get the results below. Now, my suggestion, and I will do that when I go through the examples for you, is to also print out the city. I would probably say select F name, L name, city from member details where city equals big city. Yes, I will get a third column that says big city all the way down, which is kind of redundant data. Okay, but I can double check it because I can check to see that indeed that the only city that's there is big city. In this case, I really have to just assume that these three people were in big city, that I had done my SQL statement correctly. Let me do that. Where statement. You can also use all the operators we saw before, like from films where year released is less than 1977. Be careful of less than and less than or equal to. If you want before 1977, it's less than. If you want to include 1977, then indeed we have less than or equal to. There's some try it outs in your book, and I'll go through some of those when I do the PowerPoints with you, but also you want to look at those. So in this case, I want anyone who joined in January of 2005. And so if you notice, we have date of join greater than or equal to January 1st and less than or equal to January 31st. Note that you cannot say where date of join is greater than this and less than this, less than or equal to. You have to repeat your field name again every single time. Very similar to when programming, if you're doing programming. Date diff is kind of a neat function. We're going to look at a lot more functions in the future. Date diff gives you the number of days between two different dates. If the data type in that field is a date, D-A-T-E, a date. So date diff, date 1, date 2 will return a integer, which is how many days there are between the two. Another really cool little function is cur date, which gives you today's date when you do that. So if you did something like this one, okay, let's look at this one. The difference between the cur date and the date of birth. That's how many days a person was alive. You divide by 365, that's going to give you how many years, approximately, we're assuming 365 days in a year, is greater than 16. So we're going to find everybody that's greater than 16 years old. Okay, and so that works really kind of nice when you want to do something like differences in dates. Okay, look at their philosophy on how it works starting on page 60. Okay, when you do that. As we get more complicated, I'm ignoring that. As we get more complicated statements, as we get more complicated select statements, do them piece by piece. First, figure out what tables you need. Okay, then figure out your select and your wheres, and then your froms, and then your wheres, and then your order bys. Do it step by step, and I'll do that when I do my examples for you. Narrow it down piece by piece as you go through. Logical operators and precedents. Precedents, what do you want to do first? Always parentheses always wins. Always wins. Then comes not, and, alls, any between, like, in, or some, but don't worry about those too much. We'll see some of these. They're actually really neat little operators. Any, between, in, like, or some. Most common for you to remember is that and always beats or. So, if we look at this top one, beware of precedents. You're actually going to get anybody in Golden State that joined after August 1st, or all the people in New State no matter when they joined. That's probably not what you wanted. You probably wanted the people that joined after August 1st that were in one of the two states. And so notice the bottom one of this, you put the parentheses in there, and then it works out. So if you have A and B or C, it will do it correctly, the way you probably wanted it. But if you do A or B and C, it will do the B and C first. You can always use parentheses. Notice the bottom one here. What are you going to get? All the rich people in Florida and anyone who lives in California. Maybe that's what you wanted. Okay, if that's not what you wanted, then what you want to do is put your parentheses around the first two parts. Okay, state here, and then we get all the rich people in California or Florida. Here's a try it out on page 64 of your book when you do that. So anybody that lives in those two towns and anyone whose birth dates were, the old folks and the young folks, I guess. They were born later than 89 or before 45. Parentheses, a wonderful thing. You can negate with not. The other way to negate is this little less than or greater than. Don't put a space between here, and that means not. And so you can say where not state equals California or state not equal to California. You can't use exclamation point equals when you do that. You do that in some languages, but not here when you do that. The second one kind of makes a little bit more sense, but use whichever one. Doesn't really matter. So here's where we have all the members who do not live in Golden State. Both of these are the same. You can say not state equals Golden State or where state does not equal Golden State. Exact same results. And you can use your parentheses again, not brackets, parentheses. It says brackets, but parentheses. So I want everybody that's not in one of those three towns. I could just say city equals those, that or that or that, not. And then when you do that, it negates it. Just remember that negates it. Between, greater. A lot of times simpler than less than or equal to, greater than or equal to. So you can say if age is greater than or equal to 10 and less than or equal to 21. Or you can say we're age between 10 and 21. Notice you don't need parentheses. It does include the endpoints. Keep that in mind. So if you want somebody greater than 10, okay, you don't want to include the 10-year-olds, you cannot use between unless you use 11, obviously. If you use it correctly, you can use it for both numbers, text, and dates. All works really nice as you go through. There's a try it out on page 67. You ran that in your SQL script. You might look at that. I do want to make a note. There were a couple errors in the script for your book. And so I did make those changes in the scripts supplied to you to take care of it. It had something to do with a primary key, which we'll talk about later. Some of the numbers here were repeated, and I made sure that they weren't so that we could fix it later. Don't worry about that. Just realize that your data might be slightly different than what you see in the book for the ones that we ran for you. So notice this one, between. I want the years in the 80s. Remember, it does include the endpoints, and the ratings were between 2 and 4, which means it's 2, 3, and 4. And it is on a DVD. The bottom one, I want anything that, I don't like films from the 60s for whatever reason, right? So years released not between 60 and 69, and film name between P and T. Now let's think about that. They'll give me all the P's, Q, R, S's. But remember, it's greater than or equal to, so actually if there was ever a movie named T, just T, it would include that as well. Like. We use this quite often. It's like wildcard when searching, kind of like using wildcards when searching. There's two ways to do it, but I would suggest you use the first one because it's more universal to other database management systems. A single underscore means a single character. A percent means, and this says 1 or more, but that's not correct. In MySQL, it's 0 or more when you do that. So make sure you recognize that's 0 or more. Some database management systems are case sensitive. Ours is not, so we don't need to worry about that. So if I had something like this and realize this is 2 underscores, but PowerPoint makes it look like 1, okay, the last name would have to start with a D, have any 2 letters, have the letter R, and then 0 or more afterwards. So the last name could be Deer, D-E-A-R, D-E-E-R, Deering, D-E-E-R-I-N-G, okay? This one has to have those 3 letters in that order somewhere in it. It could be the beginning, doghouse, okay, a house dog, okay, the doghouse, if it was all one word, whatever, as long as it has those in it. And notice we can say not like, we can still use that not again. So anything that does not start with the letter J. Top one we use pretty often. A lot of times you want to order people by their areas of the country, and we can do that by zip codes. And so we'll get everybody whose zip code starts with 65. It can have anything after you want. This one is anyone who does not live on a road or a street, or at least those are the ends of their addresses as you go through and do that. In acts like a set of ORs. Really good when you have a lot of choices. So you can say where init equals A, or init equals B, or init equals F, or where init in A, B, F. When you're picking pieces of, especially when they're whole numbers. So I don't like films that were released in years that end in 7s. And I want a rating. All right, I do like films that were released. I could say not in, and I would not like them. But I say in those, and I want a rating of 4 or 5. You want to order your rows often. So we have select from, where, order by. Now those 4 phrases have to be in that order, and the only ones required are the select and from. The default is order by ascending, but you can add DESC at the end, and it will order it ascending, largest to smallest instead of smallest to largest. Usually a column in the order by is in the select, but it doesn't have to be. I would, again, add that in if I were you. So if you look select salary from EMP where salary is greater than 30,000, rich people, alphabetically. But unless you actually put their last and first name in here, you wouldn't know you really got the right answer, and we're here to learn. And so I would probably do select salary, comma, last, comma, first, or in whatever order you want, from EMP where salary is greater than 30,000, order by last, first, alphabetically. Last name's the same, then they'll order by first name, so Mickey Mouse will come before Minnie Mouse when you do that. All right. Top one here, kind of odd. They order by last name. If the last name's the same, then the date of birth. I really don't know too many people whose last names and date of birth are the same, but if they are, then they'll order by first name. And notice the bottom one here, date of birth descending. You get the youngest people first, listed first. You can join columns. It's called concatenation. Now, it has nothing to do with the underlying database. It just makes it so the printout has a different title. Okay, I'm sorry. The printout puts columns together when you do that. You might want to put their whole street address together or something of that sort, but it really does not change the underlying database. It's different for different databases. SQL Server uses a plus, but we're using MySQL, so we're going to use a function, concatenate. So if I say select concat first, comma, and notice this is in quotes with a space between it, last it will say Mickey space Mouse as employee name. And aliases, I may not have mentioned that. If an alias has a space in it, it must go in quotes. If an alias doesn't have a space in it, the quotes are optional. You can use numeric data without a problem. Okay, and that would be the same as this. I don't tend to use the WS. Okay, that means white space. It concatenates it. It puts it together, separated by a white space. I just put the space in myself. Okay, so if you look at the top one, okay, concatenate first name space last name as full name. from member details where city equals big city. That's the way we're going to do it. Just an FYI for some of you. Okay, if you take 250, we'll be using SQL Server. You have to use a plus sign instead. Often used to display names first and last as one field, or combined city, state, zip, or whatever. Again, does not change your underlying tables at all. So, extracting information, very powerful feature. And here we've only done one table, whoopee. Okay, but we're going to look at how to do it from multiple tables starting in Mod 3, and it becomes a very, very powerful tool for us to use to get data back out of our database. Thanks.